Have you ever really stopped to wonder how an AI thinks? I mean, not the crazy sci-fi stuff, but how it actually tackles a real-world problem, like finding the best way to get from point A to point B. Well, today we're going deep on one of the most fundamental ideas in all of artificial intelligence, search. We're going to break down a classic MIT lecture and see how this one simple concept can scale from just navigating a city all the way to understanding Shakespeare. Let's get into it.
This quote just nails the problem, doesn't it? Imagine you're in a new city and you've got to get somewhere. You know there isn't just one way to do it, there are tons of paths. Some are awful, some are okay, but somewhere out there is the perfect route. The real challenge, for us and for an AI, is how do you find that one perfect path without getting hopelessly lost along the way?
So to make this really hit home, we're going to use this brilliant analogy from the lecture. This quote, picture 3 different cab drivers all trying to get across town. Each driver represents a totally different way of searching, a different way of thinking through the problem. Okay, let's look at these 3. First, you have the thief. Their route is just wild. All over the place, meandering, pure chaos. They get there in the end, but man, what a mess. Then you've got the beginner. They find a pretty decent path, it makes sense, it's not crazy, but it's definitely not the fastest. But then, you have the PhD. They find the optimal solution. And this isn't just a slightly better path. It represents a totally different, more intelligent process, one that actually considers the options to find the absolute best one. So, we've been talking a lot about maps and paths, but here's where we take a really important turn. The lecture makes it super clear that while maps are a great way to visualize this, they aren't what this is really about. The core idea is way, way bigger.
And here it is. This is the gold star idea of this whole explainer. Search isn't about geography. It's a model for any problem that involves making choices. Think about it. At every intersection on a map, you have to make a choice. When you play a game of chess, you're choosing a move from all the possibilities. When you plan a project, you're choosing the next logical step. So here's the kicker. By figuring out how to search a map, we're actually building a blueprint for how an AI can make smart decisions about, well, pretty much anything.
All right, so how does a computer actually do this when it can't just look at a map and see the best path? Well, it starts with what are called blind methods. You can think of these as the brute force workhorses of AI. They just systematically explore every single possibility, but they don't have any real sense of direction, no clue if they're getting warmer or colder.
And these are the 2 big ones. First, there's depth-first search. This is the single-minded, hyper-focused approach. It picks a direction and just goes, full steam ahead, down one path until it hits a dead end. Only then does it backtrack to the last place it had a choice and try a different route. On the other hand, you have breadth-first search. This one is super cautious and methodical. It explores all of its immediate options first, then it explores all the options one step away from those. It expands its search outward, layer by layer, like ripples in a pond.
Now you might be thinking that these 2 completely different strategies must need totally different, complicated algorithms, right? But this is where it gets really elegant. Both of them are controlled by one incredibly simple thing, a queue. That's it. You can just think of it as a to-do list of paths that the AI needs to check out.
And the process itself is this beautiful, simple loop. Step 1, you grab the first path off your to-do list. Step 2, is this the goal? If it is, awesome, problem solved. If not, step 3, you figure out all the new places you can go from where you are, and you create a bunch of new, slightly longer paths. And finally, step 4, you add those new paths back to your to-do list. That's the whole thing. This one simple loop, repeated over and over, is the engine that drives the entire search.
So how do you get that obsessive, plunge-ahead behavior of depth-first search? It's so simple, it's brilliant. When you find those new paths, you just add them to the very front of the to-do list. That means the next thing the algorithm does is immediately explore the brand new path it just found, which pushes it deeper and deeper. It's like always working on the newest task you just thought of.
And what about that cautious, level-by-level breadth-first search? You just make one tiny change. You add the new paths to the back of the queue instead. This forces the algorithm to work through all the paths it already knew about at its current level before it ever gets to the new ones. It is just incredible that this one tiny tweak creates a completely different strategic behavior.
Okay, so blind search works, but you can imagine it can be really inefficient, right? It could spend ages exploring paths that are obviously going in the wrong direction. So how do we make it smarter? The next level up is to give the AI what's called a heuristic, which is basically just a fancy word for a rule of thumb or an educated guess that helps it figure out which paths look the most promising.
And this gets us to informed search methods.
Hill climbing is like a smarter version of depth first. It still plunges ahead, but every time it has to make a choice, it uses its heuristic to pick the path that seems to be getting closer to the goal. Then you have beam search, which is like a smarter breadth first. It still explores level by level, but instead of keeping track of all the possible paths, it only keeps a small handful, a beam, of the very best ones, and it just throws the rest away. This stops the search from getting bogged down exploring thousands of obviously bad routes.
This table just ties it all together so perfectly. You see the two blind methods, depth first and breadth first? They're basically identical. The only difference is where they add new stuff to the queue, front or back. Then you look at the informed methods, hill climbing and beam search. They're just the same base strategies, but with an added layer of intelligence, a heuristic, to guide them. This simple, elegant toolkit is really the foundation for how AI solves these kinds of problems.
Okay, so we've been deep in the weeds on how these search algorithms work, but now we get to the really cool part, the big payoff. Remember that huge idea from earlier, that search isn't really about maps, it's about choice? Well, let's see just how mind-blowingly far that idea can actually take us.
And this is the question that just changes everything. It seems like a massive leap, right? I mean, we've been talking about concrete streets and intersections. Shakespeare's abstract. It's about themes and motivations and complex human drama. How on earth could the same logic possibly apply?
Well, the connection is all about structure. You can represent a story not as a map of streets, but as a graph of connected ideas, characters, and actions. Macbeth kills Duncan. Duncan was the king. Macduff kills Macbeth. Each of these is a point on the graph with a connection. So a complex theme, like say revenge, is just a specific pattern in that graph. Someone is wronged, that causes anger, which leads them to harm the person who wronged them. An AI can use the exact same search algorithms we've been talking about to hunt for that specific pattern inside the story's graph.
And this is the final, absolutely mind-bending piece of the puzzle. The AI isn't just finding a single path to a single goal anymore. It's running multiple searches for all these different thematic patterns. And then, this is the key, it can report on the results of those searches. It can say, hey, I found an instance of that revenge pattern right here. Or this event is part of a bigger pattern that looks a lot like a Pyrrhic victory. It's using the act of searching to build a kind of reflective, abstract understanding. So think about where we went. We started with a simple problem of finding a path on a map, and we ended up with an AI that can analyze themes in literature. And that journey forces us to ask this really profound question. How many of the things we do, the skills we think of as uniquely human, planning a trip, diagnosing an illness, even composing music, are really at their core just a search problem in disguise? Just a matter of finding the right path through a huge space of choices. That's something to think about.
Follow for more.